Well, good evening. This is lesson 8.3, and it's going to take the idea of angles that we just developed in the previous lesson, and it's going to take it a little bit further. And there's a very strong difference, too, between the two lessons. In 8.2, we talked about the basics of angles, what they are, how to make them, the two rays, the vertex, and how to measure them using a protractor. Now in 8.3 we're going to talk about angles in a very different way. We're not going to do any measuring in 8.3. Instead, what we're going to do is we're going to talk about different kinds of angles and how angles go together. So let's start with our first definition, and our first definition is going to be complementary angles. Now you might think that complementary angles are angles that just really get along well and they tell each other how cool they are. Well, that's not quite what complementary means in math. What complementary means in math is we're talking about two angles that if you added the two angle measures together, and you could literally picture this visually by literally imagining if you just took one angle and you literally slid it right up next to the other angle, and the two angles together would basically make one big right angle. Okay? Now, the two angles don't have to be next to each other. They don't even have to be facing the same way. So you could have two complementary angles, one angle that looks like this, okay, and another angle that looks like this, just as long as the measures, if you put them together, let's say this one is 30 and this one's 60, and if you add those together, sure enough, they would add up to be 90 degrees. Okay, and that's called a complementary. It's actually called a complementary pair, or we could say the two angles are complementary angles. Okay, and a lot of times we give the angles names, so let's call this angle 1 and angle 2. So we could say that angle 1 and angle 2 are complementary because when you put them together, they add up to 90. All right, now we have a very similar idea to complementary, and it's called supplementary. All right, and what supplementary angles are is exactly the same thing. Supplementary angles, a supplementary pair, you can call them either. And now we're talking about two angles that add up to be 180 degrees. Okay, so that'd be two angles like this. So again, let's say that we have a 30-degree angle and we have a 150-degree angle. That's a 5. Okay, sure enough, if I add those together, it equals 180 degrees. Okay, so any two angles that add up to 90 are called complementary, and any two angles that add up to 180 are called supplementary. Now, an interesting pair of supplementary angles would be any two right angles. So if I take a right angle like this, and then I take another right angle like this, okay, those two angles, because they're right angles, they're both going to add up, each of them adds up to 90. So they're automatically going to be supplementary. So you could say any two right angles are supplementary to each other. All right, let's talk about the next angle relationship. For this, what we're going to need is we're going to need two lines that cross each other like this. Okay? Some people call these bow tie angles. We're going to talk about the angles that are across from each other. So again, let's give them names. Let's call this angle 1, this will be angle 2, this will be angle 3, and this will be angle 4. All right, now just looking at angle 1 and angle 3, I think you can probably tell that those two angles are you can probably tell something about them. And what's going to be true about them is they are going to be the same measure. Okay, another way to say that is you could say that the measure of the two angles is equal. Okay, the name for these is called vertical angles. Now this is kind of like the word that means up and down, vertical, but it means something different in this case. Vertical angles are angles that are across from each other. In fact, if you look at angle 1 and angle 3, they're not up and down, they're kind of side to side. Okay, now there's another pair of vertical angles here too. Angle 2 and angle 4 are also across from each other, so they would be equal to each other. Okay, so basically when you have two lines that cross, generally speaking, you're going to get a pair of acute vertical angles, like 1 and 3, and you're going to get a pair of obtuse vertical angles like 2 and 4. In fact, the only time that's not going to be the case is when your two lines cross and are perpendicular. And in that case, you still get vertical angles that are across from each other, but you won't get a pair of acute ones and a pair of obtuse ones, because basically what you're going to get is 4 equal right angles. So that's really the only exception. Okay, so that's what vertical angles are. All right, the final kind of angles that we're going to talk about come from when we have a pair of parallel lines. Okay, they don't actually have to be parallel lines for all of the terminology that I'm going to talk about here, but let's assume that we have a pair of parallel lines. Okay, and so let's go ahead and make these lines. I should have put these on all of them. I should put little arrows on these. And the way we indicate that lines are parallel is we put little extra arrows kind of inside along, almost like feathers on an arrow. And because these two symbols match, it means that the two lines are parallel. Again, let's give our angles names. So we'll call them 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so kind of, put your seatbelt on for a second because we're going to actually talk about several different vocabulary terms. First, let's talk about interior angles. The interior is referring to the two parallel lines. So interior are any angles that happen to be between the parallel lines. So the interior angles would be 4 and 3, 5 and 6, because all four of these angles are sandwiched inside the parallel lines. Well, if the blue angles that I just circled are called interior angles, I bet you have a pretty good guess of what the 1, 2, 7, and 8 are called. And sure enough, they're called exterior angles. Okay, so the exterior angles, exterior angles are going to be, we're going to put boxes around these, 1, 2, 7, and 8. Okay, now there's also another special term in this video, or in this diagram right here. Sorry. Got a little frog in my throat right now. And that is going to be the name for this line right here. This line that cut across the other two lines. I want you to think back in American history when the first railroad went all the way from the East Coast of the United States to the West Coast. They called it the Transcontinental Railroad. And the reason for that is because trans means across. Okay, Trans-Pacific would mean traveling across the Pacific Ocean. Okay, the Titanic was an ocean liner that was called the transatlantic liner because it went back and forth across the Atlantic Ocean. So trans is a prefix that means across. And so from that prefix, we have the word transversal. Now the transversal is a little different than the interior and exterior. That described angles. The transversal describes a line. And it's this line right here that cut across my two parallel lines. Okay? So these angles that we just were talking about, the interior and exterior angles, are formed by a combination of one of the two parallel lines and the transversal. Okay? Now, when the lines are parallel, we get some very interesting relationships. Okay? If you look very closely at some of the numbers, I want you to look at all of the even numbered angles, 2, 4, 6, and 8. And this is just how I happen to label them. So, if you label them differently, it might be a different set of angles. But look at all of the angles, 2, 4, 6, and 8. Notice something about them all. If you look closely, you're going to notice that they're all obtuse angles, aren't they? And if you look even closer, we already know that 2 and 4 have to be equal. We just learned that a second ago because they're vertical angles, correct? Okay, so if 2 and 4 are equal, well, we also know that 6 and 8 are vertical angles, so they're equal. And it turns out there's one more relationship. When the lines are parallel, it turns out that angle 4 and angle 6, they have a special name. They're called alternate, I'm just going to abbreviate this, interior, using that word that we just had a second ago, angles. And there's a theorem in geometry that says if you have parallel lines cut by a transversal, the alternate interior angles are going to be congruent, which means angle 4 and angle 6 are congruent. Now, if you follow all that along, if I know that 2 is equal to 4 because of vertical angles, and if I know because of what I just said that angle 4 is equal to angle 6, and I know that angle 6 and angle 8 are equal because they're vertical angles, then essentially all 4 of these vertical angles, or all 4 of these even numbered angles in this diagram, are all going to be congruent. They're all going to be the same angle measure. And I can extend that, if I want, to some other angles. Sure enough, I can do the same thing with the odd angles. So this angle here, angle 1, is going to be a vertical angle with angle 3. Angle 3 and angle 5 are both interior angles, but they're on alternate sides of the transversal. That's what the alternate refers to. Okay, so they're one is on the up and right side of the transversal, the other one is down and on the left, and they're on separate intersections too. One is where the transversal crosses the top parallel line, and one is where it draws across the bottom parallel line. So 3 and 5 are alternate interior angles. So 1 is the same as 3. It's congruent to 3. Congruent just means the same in geometry. 3 is going to be congruent to 5 by parallel lines imply that alternate interior angles are equal. And then 5 and 7 are also vertical angles. So you can get these very cool relationships. Okay. By the way, There is something called alternate exterior angles as well. It's basically the exact same idea, and we'll talk about that in class. But I think that is probably enough vocabulary for one lesson. Interior angles, exterior angles, transversal, complementary, and supplementary. Those are the terms you need to know. So complementary, one more time, let's just review these. Complementary means the angles add up to 90 degrees. Okay, supplementary means they add to any two angles that add up to 180 degrees. Okay, complementary 90, supplementary 180. A good way to remember that, some people get them confused. Complementary, since it starts with C, it comes first in the alphabet. It's the smaller angle. Supplementary comes much later in the alphabet, and so that's the bigger one. Okay, so the small letter goes with 90, the big letter goes with 180. Vertical angles, anytime you have two straight lines cross, and it's important for them to be lines. These would not be vertical angles, even though they're across from each other. So you have to have two straight lines. You can't say that this angle 1 and angle 2 are vertical angles because those aren't straight lines. Okay, so you can't have that happen. And finally, a much more complicated diagram, but not if you really look at it closely. When you have a pair of lines cut by a transversal, we get exterior angles, we get interior angles, and then we also get this notion of alternate interior angles that we'll talk about a little bit more in class. Okay, so we'll talk more about alternate interior angles. We'll introduce alternate exterior angles. We'll also talk about something called corresponding angles. Okay, and we'll do some practice problems, and that's it for tonight. So thank you very much for watching, and I'll see you in class tomorrow, everybody.